We default to thinking of cause and effect like billiard balls. One event strikes another, triggering a direct physical outcome. If you ask what caused the glass to shatter, you point to the cue ball. If you try to force Aristotle's ancient philosophy of nature into this linear, sequential timeline, his famous analytical framework, the four causes, sounds completely archaic. The biggest point of friction is what he calls the final cause. Post-Enlightenment readers usually assume he is talking about a conscious watchmaker, some external divine designer mapping out nature on a drafting board. But the actual Greek word Aristotle used is ateon, and ateon is not a physical trigger. It is a multidimensional explanatory factor. It is simply the answer you give to a specific kind of why question. Imposing our linear definition of causation onto his work completely obscures the mechanics of his biology. It renders his greatest scientific achievements entirely unreadable. Look closely at these ruins. This is the Lyceum in Athens. Aristotle used this physical space as a massive research facility. His biological studies, which make up roughly 25% of his surviving writing, were the rigorous testing ground for his entire philosophy of science. Here, he confronted a massive problem. Moving from the superficial chaos of everyday observation, thousands of animals and millions of variations, into a structured system of causal knowledge. His solution was a strict two-step epistemic pipeline. A researcher must prove that a fact exists completely independently before they are allowed to investigate why it exists. In his vocabulary, you move from the hoti, the establishment of the fact, to the dioti, the search for the reason why. To execute this pipeline physically, Aristotle deliberately fragmented his biological research into distinct texts. In doing so, he invented the formal architecture of scientific literature. This fresco famously depicts Aristotle holding his ethics, but the actual rulebook guiding his biological work is a text called the Posterior Analytics. It serves as his manual for scientific demonstration. The Posterior Analytics dictates that scientific inquiry must proceed in paired sequences. You must secure the sheer existence of a subject and its attributes before you can pursue the causes behind them. The immediate target of this initial observation is to find convertible universals. These are biological traits that perfectly coexist across a specific group of animals. Securing these coextensive relationships is an absolute prerequisite. You cannot build a demonstrative science on exceptions or partial overlaps. You need an ironclad correlation to serve as the foundation for your eventual explanation. This strict framework forces discipline. It prevents researchers from jumping to theoretical conclusions before the raw boundaries of a biological category are firmly established by observation. Aristotle executed the first half of this pipeline, the hoti investigation, in his massive treatise, The History of Animals, or more accurately translated, Animal Inquiries. His methodology here relies on multi-differentiae division. He meticulously cross-references parts, activities, and habitats to organize the data, deliberately avoiding any attempt to explain it. Look at this papyrus fragment representing Historia Animalium 505b23. Aristotle is mapping the internal organs of blooded animals. He writes, "Generally, all and only those receiving air by inhaling and exhaling in every case have a lung, windpipe, and esophagus." He has isolated his convertible universal, an absolute correlation between the act of breathing and the presence of these three organs. Notice the exact vocabulary he uses. Across this entire description, there is zero mention of purpose, necessity, or cause. The History of Animals successfully isolates the explanandum, the specific facts to be explained, while maintaining complete theoretical neutrality. The data is prepped. With the facts secured, the pipeline shifts to the dioti phase, the search for the reason why these anatomical structures exist. This chart shows how Aristotle maps his four causes. Instead of a linear timeline of events, we need to picture a four-quadrant matrix of explanation. Two quadrants explain the organism statically. The material cause asks what the animal is made out of, its tissues and fluids. The formal cause asks what it is to be that specific animal, the structural definition of the species. The other two quadrants analyze the organism dynamically. The efficient cause identifies the source of its generation, what produces it, and the final cause identifies what the organism or its part is for. In biology, Aristotle's final cause is completely internal. The functional capacity of the animal to live its life is the goal. The bodily parts exist for the sake of that internal function. Applying this matrix transforms biological teleology from a mystical theology of intelligent design into a rigorous, observable system of functional biology. To see this applied, we turn to Aristotle's explanatory treatise, Parts of Animals. He returns to the exact same anatomical correlation established earlier: the lung, the windpipe, and the esophagus. Look at the two texts side by side. In Parts of Animals 664a14, there is an abrupt syntactic shift. The language is suddenly dense with explanatory vocabulary. He repeatedly relies on the words nature, necessity, and for the sake of. He is deploying a highly specific conceptual tool here called conditional necessity. Conditional necessity dictates that if an animal is to achieve the functional goal of respiration, its final cause, then the physical presence of a windpipe is materially and formally required. The outcome necessitates the parts. Parts of Animals takes the raw, neutral data correlations secured in the Hody step and transforms them into a robust causal demonstration of the dyody. This leaves us with a glaring historical puzzle. Why did Aristotle physically separate these stages of research into entirely distinct books, rather than writing a single, unified biological text? It is easy to assume this separation was a historical accident, a drafting error, or the meddling of medieval editors assembling fragments centuries later. In reality, Aristotle was neutralizing a severe methodological danger. Mixing data collection directly with causal explanation inevitably leads to confirmation bias. If you search for the cause while you are still defining the facts, your logic becomes circular. Isolating the facts to be explained is a non-negotiable prerequisite. You must have a clean dataset before you can accurately assign the causal explanations. The physical separation of these treatises was a deliberate firewall. It was engineered to prevent theoretical bias from infecting empirical observation. Viewed this way, the Aristotelian corpus is a massive workflow pipeline. Posterior analytics provides the foundation, Historia Animalium funnels data upward, and Parts of Animals outputs causal explanations. This architecture of inquiry remained the most sophisticated scientific methodology until the 16th century. A single, linear, triggering view of cause and effect simply fails to capture the systemic complexity of a living organism. Aristotle's method of prioritizing internal function and mapping conditional necessity directly anticipates the rigorous frameworks we use in modern systems biology today. Cataloging the animals of the ancient world was only a byproduct of his real achievement. He engineered the permanent, formal architecture of scientific inquiry itself.